All right, so 7.1 is called the Pythagorean Theorem. Okay, it basically talks about exactly that, which is something some of you already know. But then we're gonna like review the square root stuff, you know, how to simplify all that stuff, because all that will happen with this section. Okay, so in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the lengths of the legs, or a squared plus b squared equals c squared. The important thing there is that c, good, is the hypotenuse. How would you know it's the hypotenuse? From a drawing. Opposite the right angle. How would you know it's the hypotenuse if I just gave you three lengths?
Maybe the last one.
Longest, right? Longest side. Okay, so sometimes you're going to get the actual triangle. Sometimes you're going to get the actual values and not the triangle. So remember that the hypotenuse is the longest side, or the side opposite the right angle. Other than that, A and B can be interchanged. It doesn't matter where their location is. Okay, common triples. So these are combination of numbers that when plugged into a squared, b squared, and c squared actually still work. They're the most common, okay? 3, 4, 5, 6, 8, 10, 5, 12, 13, and 7, 24, 25. So that means that if A was 3 and C is 5, you can automatically assume B is 4. If you were given 3, 4, and the hypotenuse is missing, then you can automatically assume it's 5. Or any combination of those. So if it was 6, 8, the third one's 10, as long as the hypotenuse is what's missing. So just be careful with these. These are like shortcuts, but be careful with them, because if I gave you a triangle and I said this is 3 and this is 4, is that missing side 5? No. And how do you know that? Because it would have to been the longest side, right? It has to be the hypotenuse, which doesn't work. So for that, you'd use your Pythagorean theorem. Does that make sense? Okay. So 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25. Never seen a standardized test that doesn't use one of them. Okay? If the idea is that they are helpful, shortcut, you can find it still using the Pythagorean theorem, but it will save you a lot of time. All right, so this says find the values of x and y. So we start off nice and easy. How do I set this up? What will go by itself? The y, right? So this would be 5 squared plus 10 squared equals y squared. 25 plus 100, 125, and then y equals. Technically, it's plus and minus the square root of 125, right? But there's no such thing as a negative side length, so we only take the positive. Now, is 125 a perfect square? No. Right? Think it would be in between 121, which is 11, right, and 144, which is 12.
Oh, yeah.
But is this simplified? We don't know yet, right? We got to break it down. So what number goes into 125? 5 and 25. What number goes into 25? 5 and then 5. Remember, for every pair of numbers, one of those goes to the outside of the square root. So I bring 1, 5 out by canceling those two, and what's left is 1, 5 underneath. So the exact answer is 5 root 5. If it had told me to estimate, think 125 is in between 121, which is 11 squared, and 144, which is 12 squared. And it's closer to 11, to 121, right, than it is to 144. So I would say this is like 11.2, but it is just an approximation. So if it said to estimate, that's what it means, okay? If it says to keep it exact, you would leave it as 5 root 5. Questions on that one? Okay, B, what goes by itself? The y. So this is 5 squared plus y minus 1 squared equals y squared. What do you do with y minus 1 squared? This is 25, right? Is that y squared plus 1? No, you got to expand it and FOIL it out, right? Y minus 1 times y minus 1. So this is 25 plus first, y squared, outer, negative y, inner, negative y, last, positive 1. Combine my like terms, I'd get y squared minus 2y plus 26 equals y squared. Then what?
Yeah, y squared.
Gotta subtract the y squared. Cancels from here, and it also cancels from here. Then what could you do?
Then you add 2y.
Good. Can you check these answers?
Yeah.
How?
Plug it in.
Plug it back in, right? So we said this would be 5, this would be 13 minus 1, which is 12, and this would be 13, and that's one of my triples, right? 5, 12, 13, but if I didn't see it, I could do 5 squared plus 12 squared and see that it's 13 squared, which is 169. Questions on that one? So it's going to force the algebra review inside Pythagorean Theorem. It's good for you. Okay, now go to C. What should be by itself?
The 3 squared.
Good. So I get x squared plus 3 squared equals 3 root 2 squared. So I get x squared plus 9 equals, now this is 3, you could look at this two ways. 3 squared times root 2 squared, or 3 times root 2 times 3 times root 2. Either way, there's 2 3's, right? So 3 times 3 would be 9. And what's root 2 times root 2? 2. So I'd get x squared plus 9 equals 18. And then what? Subtract the 9. X squared equals 9. Square root both sides, and like I said before, normally it's plus and minus, but because there's only positive side lengths, we ignore the minus and just keep the positive side length. Okay, example 2 says find the length of a diagonal of a rectangle with length 8 and width 4. So first thing is we're starting out with a rectangle, right? It says length is 8, width is 4. If I want to find the diagonal, you can go either corner, but one way to the other. Let's see if I can get it straighter than that. Okay, that would be one of the diagonals. Again, I can go top left, bottom right, or top right, bottom left, doesn't matter, right? What did I just make? 2 right triangles, right? So it doesn't matter if I would do the 8 on the bottom or the top, or the 4 on the right or the left. Good. These are 2 congruent right triangles.
So 8 squared plus 4 squared equals 4.
Perfect. Okay, this is my diameter, right? I mean my diagonal, so let's say it's C. 4 squared plus 8 squared equals C squared. And I get 16 plus 64. C equals the square root of 80. Is 80 a perfect square?
No.
Nope. Break it down. What goes into 80? 2 and 40. 2 and 20. 2 and 10. 2 and 5. For each pair, one number goes to the outside. And there's a 5 left. So I get 4 root 5.
Can you do like 4 squared, or do you have to do 2 times 2?
No, you could do 4.
Oh,
Yeah, you could do 4, and I mean, you could have done like, 5 and 16, and then 6 square root of 15. Any way you break it up, yeah. Questions on that one? All right, example 3 says the diagonals of a rhombus have lengths 16 and 30. Find the perimeter of the rhombus. So what do you know about a rhombus?
The diamond.
It's like a diamond, yeah.
It's two congruent triangles.
Yeah. Okay, it's got 4, oh, that's not right, but it's got 4 congruent sides. Okay, they tend to be slanted like that. Okay, doesn't mean they have to be. But what you do know about, by definition, a rhombus has 4 congruent sides. So if it says the diagonals, that means I'm cutting across it. And one is a length of 16, so let's say the teal one is 16. And the other has a length of 30, so let's say the blue one is 30. What happens with diagonals is they bisect each other. So these are cut into 2 individual parts. So there's a lot of different ways to look at this one. Basically, you've taken 4, there's 4 smaller congruent triangles because vertical angles would make the angles congruent. The sides would be split in half, so they'd be the same, okay? But one way or the other, so let's say I go, this is 8, this is 8, this is 15, this is 15. The other thing about these is that they are perpendicular. So this hits at a right angle. So now I've got 4 congruent right triangles, okay? So if I want to find C, that would be the hypotenuse. I would do 8 squared plus 15 squared equals C squared. Was this one of the triples I gave you? Yeah, right. So C is 17. That's how easy a triple is. If you don't know it, you have to do 64 plus.
No, this is not one of them.
It's not one of them? Okay, we'll add it to it. Plus 225, that's 9, 8, 2, and the square root of 289 is 17. So go back to your triples page because 8, 15, 17 is a triple. And add that one on. 8, 15, 17, yep. So that's the length of one hypotenuse. How would I find the perimeter?
Times 4.
Good. There's 4 of them. So 17 times 4. 68. The standardized tests love these kinds of questions, right? They don't usually ask straightforward Pythagorean theorem, but they will ask stuff like this that uses the Pythagorean theorem. Questions on that one?
So what was the numbers again for
All right, the last one. Okay, you've got a, what kind of triangle is the big one? The big one is isosceles, right? And then when we draw in our altitude, right? Go back, way back to chapters, right? That vertical line is altitude, and the altitude does what to the base? Cuts it in half. So that 6 gets divided into 3 and 3. And now I've got, again, 2 congruent right triangles. So if I want to find x, they're both the same. It doesn't matter which one I pick. I would do 3 squared plus 6 squared equals x squared. 9 plus 6, 36 equals x squared. 45 equals x squared. X equals the square root of 45, which is 5 and 9, or 3 and 3. So this is 3 root 5. Camilla.
How would you know that you have to divide 6 by 2?
So if you have an altitude, which is what that line is, right, because the right angle. If you have an altitude that intersects the base of an isosceles triangle, it cuts it into 2 congruent parts. So it only works on an isosceles triangle like that. If this was any other triangle, it wouldn't work that way.
Okay.
It has to be isosceles, but we know it's isosceles because both x's. Yeah.
Our altitude's like from the sides of the.
Altitude goes vertex to perpendicular of the opposite side. Questions on anything we did today? Super easy, right?
Yes.
Fun to be back. Yeah.
No.
No.